Alright, so for this lecture, we will discuss transformations in R2 and in R3. Now, let's have first R2. R2 can be also written R cross R. So R cross R meaning the Cartesian product of R with itself. So the figure of R cross R is like this. So you already know that this graph is what we call the Cartesian plane. Alright, so what can we do in this Cartesian plane? So let's have here x and y. So let's have a point. Let's say this point. So this point can be represented by uh, this notation. So we have x0, y0, where this point is x0 and this point is y0. Now, we can also express this notation into different other notations. Like, so we can explain this point through what we call vectors. So we will draw an arrow like this, wherein the initial point of the arrow is at the origin. So we call it in standard form, or in standard position rather. Now, this arrow here can be represented by this notation. So if you see this kind of notation, I'm talking about vectors, while in this notation, I'm talking about points. Now, there's also another way to represent the point x naught, y naught in terms of the angle theta. So let us first draw a circle here, wherein we have here theta. Now, if we have this theta here, so we can represent the point x naught, y naught in terms of theta be cosine of theta sine of theta, but you multiply cosine and sine by r, meaning r is the radius. So if we represent this arrow be a right triangle, so as you can see, you form a right triangle wherein this side corresponds y naught and this side corresponds x naught. So if we let the length of the arrow be r, if we represent cosine of the angle, so we have adjacent, so x naught over hypotenuse, and sine of the angle be the opposite, y naught all over r. So x naught will give you r cosine of the angle, while y naught be r times sine of the angle. And lastly, we can also represent the point using the so-called I hat. So we have here two unit vectors. So we call this vector I hat and this vector be j hat. So we may write the vector x naught y naught by this. So x naught times I hat plus y naught times j hat. So we have um, four ways to represent this point here. Alright, so we proceed at R3. So R3 can be written R cross R cross R. So you can illustrate R3 using this graph. So we are now in a three-dimensional space wherein this location corresponds to the x-axis. This location corresponds y-axis, and this location corresponds the z-axis. So if we have point here, so we can represent this point using the three coordinates. So we have here the point x naught, here the point y naught, and this point we have z naught. So we write here x naught, y naught, z naught. Alright, so using again our previous knowledge in R2, we can also draw an arrow or an arrow coming from the origin. So this vector here is in standard position. So we may write the point in vector form be x naught, y naught, z naught. And then we can also use the idea of I hat and j hat in R2 here in R3. So we may have here I hat. So here we have j hat, and for z axis we have z or k hat. So we may write x naught multiplied by I hat plus y naught multiplied by j hat plus z naught multiplied by k hat. Alright, so now I can now introduce to you the idea of parametric equation. So let's say we have a function that lies in R2. So let's have here. So at this point, so we call this point A, and this point B. Now, in order for us to get B from A, there is a notion of a particle. So let's say A correspond x0 and B correspond uh, A correspond x0 y0, B correspond xn yn. Now, let's have this point be xk yk. So to get e to get a from this point, so there's such a time t, so we let t be a parameter wherein at t equal to 0 we have the point x naught y naught. Now at t equal to, let's say, k, we are in the point xk yk, and if we have t at the point n, so we have the point xn yn. So using this notion, we can express t in terms of input to x and y. So let us write it here. So we have t equal to 0, t equal to k, and t equal to n. So this is the concept of parametric equation in R2. Now same argument in R3. So let's have first the graph. We have x, y, and z. And for example, this is your function. So we have here the point x0, y0, z sub 0. Then for this point, we have xn, yn, jn, and for the point in between, let's have xk, yk, zk. Same argument in R2. If we have t equal to 0, we are at the point x naught, y naught, z naught. At t equal to k, we are at the point xk, yk, zk. And lastly, if we have at the point t equal to n, we have xn, yn, zn. So to write it in general, so t can be in the form, so can be input to x, to y, and to z.